This is our second set of examples for section 6.4. We're going to use coordinate geometry in order to justify which type of quadrilateral or parallelogram we have. So pay attention that we are already given that we have a parallelogram. So we already have that this is a parallelogram and our diagonals bisect each other. But we're going to use the diagonals to decide whether we have the rectangle. Remember, our rectangle will have congruent diagonals. The rhombus, remember that a rhombus has to have diagonals that are perpendicular, or whether we have the square, and the square has to have both of those items. So we're going to use coordinate geometry to calculate with that. So the first thing that we need to do is to identify the diagonals, and they join non-consecutive vertices. So I'm going to start with my diagonals. So I'm going with non-consecutive vertices, so pay attention to the name. It's the two letters that are not side by side, so we're going to be working with PR, and we're going to work with QS. So P with R and Q with S. So in our next phase of the process, we're going to do the slope of each of our diagonals. Remember that perpendicular lines have slopes that are opposite reciprocals. We learned this in chapter 3. So if we calculate the slopes and they are opposite reciprocals, then we have perpendicular. If they're not opposite reciprocals, then it's not perpendicular. So we're going to calculate the slopes of our two. So I'm going to do for PQ my x coordinate of P minus the x coordinate of R, and my y coordinate of P minus the y coordinate of R. So this is going to be 7 over -4, or -7 fourths. We're going to do the same thing with QS. So I have my x coordinate of Q minus the x coordinate of S, and my y coordinate of Q minus the y coordinate of S. And this is -7 over -4 to get a positive 7 fourths. So when we look, we have opposites, but we don't have reciprocals. So these are not perpendicular. So our slopes are not perpendicular. So we go to our next calculation, and we're going to find the length of each of the diagonals. Because of theorem 613, the diagonals are congruent in a rectangle. Congruent lines have the same length. So this time we're going to go through and we're going to calculate the length of our diagonals. So for PR, it's going to be -2 minus 2 squared plus 3 minus -4 squared. So this is going to be -4 squared plus 7 squared to get 16 plus 49. So this is the square root of 65. We can leave it as the square root of 65, or you can use a calculator to estimate the square root of 65. Just make sure that you round the same place both times. So this is approximately 8.1. So I do the same thing for QS. So -2 minus 2 squared plus -4 minus 3 squared. So this is going to be negative 4 squared plus negative 7 squared. So this is 16 plus 49 to get the square root of 65, which is approximately 80 or 8.1. So these are congruent. So now when I go through to identify the parallelogram, I have only congruent. So they are only congruent. So because they are only congruent, I have a rectangle. So this is a rectangle. So let's look at another example. We'll organize this one a little differently, see if it helps. So I'm going to go through the same process. I'm going to identify the diagonals. So I'm going to work with diagonal PR. So P is at 7, negative 1. R is at negative 1, negative 1. And then my other diagonal is going to be with Q and S. So Q is at 3, 6, and S is at 3, negative 8. Now that I have my coordinates for my diagonals, I'm going to go through my calculations. So my first calculation is going to be the slopes. And then my next calculation is going to be the distance. So keep in mind that we are finding the slope of each diagonal because perpendicular lines are opposite reciprocal slopes. So we're going to use our slopes to help us with this first part. So if we identify our x1, y1, and x2, y2, and calculate the slope, this one is going to be negative 1 minus negative 1 over negative 1 minus 7. So this is 0 over negative 8, and 0 on the top is a 0. For the other diagonal, x1, y1, x2, y2, this is going to be negative 8 minus 6 over 3 minus 3. So this is negative 14 over 0, which is undefined. Now, keep in mind that undefined and 0 are not opposite reciprocals. However, when we have a slope of 0, we have a horizontal line. And when we have a slope of undefined, we have a vertical line. So these are perpendicular. So we are perpendicular. So we do have perpendicular. So we go to the distance calculation. Keep in mind that we're calculating the distance because finding the length of the diagonals being congruent. So congruent diagonals have equal length. So this goes back to that theorem 613. So we're going to calculate our lengths. So for this first one, when we fill in x2 minus x1 squared plus y2 minus y1 squared, this is going to give me negative 8 squared plus 0 squared. So this is 64, and the square root of 64 is 8. We do the distance for the other one. And we have 3 minus 3 squared plus negative 8 minus 6 squared. So this is the square root of 0 squared plus negative 14 squared. So that's the square root of 196 to get 14. And when we look at these two, they are not congruent. So these two are not congruent. So they're not congruent. So when we look at our options, I did not have congruent, and I had perpendicular, so that makes this a rhombus. So take your time through the calculations. Slopes to check for perpendicular, distance to check for congruence. So our congruence will be for the rectangle, our perpendicular for the rhombus, and a square requires both of them.